Assalamualaikum and hi students. So today we are going to learn determining the order of reaction. Method 1. Unit of the rate constant. The units of the rate constant K depend on the overall order of reaction. They are derived from the rate laws. Alright, for example, zero order reaction. Let's say we have a reaction from A converted to product. So in order to determine the order of reaction by using the unit of rate constant K, we have to refer to the rate law equation. So let's say A follows zero order, so the rate law is rate equals to K. Since the unit of rate is molar per second, thus we can determine the unit of rate constant, which is molar per second. For first order reaction, let's assume A follows first order reaction. So the rate law is rate equals to K times concentration of A. So the unit of rate is molar per second. K times concentration of A, where the unit of concentration, let's say it is measured in molar. So you can see here, molar and molar is cancelled out. Thus, the unit of rate constant K is per second. If A follows second order, the rate law is rate equals to K times concentration of A power of 2. The unit of rate is molar per second. So here is K times concentration of A power of 2. So the unit of concentration of A molar is power of 2, is squared. So you can see here, leaving K with the units per molar per second. So you can see, by using the unit of rate constant, we can recognize the type or the by using. So you can see here, by using the unit of rate constant, we can determine the. So you can see here, by using the unit of rate constant, we can determine the order of reaction. So as a conclusion, how to determine the order of reaction from the unit of rate constant? So it is summarized here. You may refer to your lecture notes. The second method is called initial rate method, and this method has been discussed in our tutorial in the third hour. Alright? So you will be given a set of data like this. For example, consider the reaction X plus Y plus Z produces products. The results shown below are obtained for the reaction between X, Y, and Z. So you can see we have 4 experimental data with concentration of each reactant. Okay, sorry, here supposed to be Y. And the initial rate for each experiment. The experiment were repeated 4 times. The question: determine the order of reaction with respect to X, Y, and Z. Determine the overall order of reaction and the rate constant for the reaction. Alright class, so let's do some revision because we have discussed this method already. So to answer question A, firstly you have to write the general rate law for the reaction. The unknown order with respect to X, Y, and Z. So rate equals to K times concentration of X let's say power of m times concentration of y power of n plus times concentration of z power of p. Alright, okay. So now we are going to, let's say I want to determine the order with respect to x. So I will choose any two datas from the experimental data where the concentration of y and z are constant. Okay. You can see here I can use the experimental data from experiment 2 and 1. Alright, okay, so now we are going to compare the rate. Rate from experiment 2 is compared with the rate from experiment 1, which is equals to K times concentration of X power of M times concentration of Y power of N times concentration of Z power of P. Okay, so substitute the data. So solving by using mathematics, you will get this, and finally you will determine the value of m, where m is the order with respect to x. Alright, so the answer is m equals to 1. Thus, x is first order reaction. Right, settle with order with respect to x. Now we are going to determine the order with respect to y. So same method. I will choose the data from experiment 3 and experiment 1. Compare the rate and substitute all the values. So solve for n, and thus you will notice that y is second order. And now let's continue with z. To determine the order with respect to z, I choose experimental data from experiment 4 and experiment 1 and solve by using mathematics. So P is equals to 0. Alright, from this method, you can see we can determine the order with respect for each reactant by comparing the rate of reaction. Okay, continue with question B. Determine the overall order of reaction. So write the rate law by substituting the value of M, N and P. So this is the rate law for this reaction. Alright. Okay. So overall order, thus it is a third order reaction. We pronounce it as third order, not three order. So how we get third order? 1 plus 2. And for question C, determine the rate constant. Since we have the rate law, rate equals to K times concentration of X times concentration of y power of 2. By using any data, substitute the values and we can determine the rate constant. So let's say I choose experimental data from experiment 1. Thus, the rate constant is 1000 molar power of negative 2 per second. The following three types of linear plots are used to indicate the order of reaction with respect to a given reactant. Let's say the reactant is reactant A. For first order reaction, if you want to determine the order of reaction graphically by using linear graph method, you have to plot graph ln concentration of reactant against time. Alright, so you will get a linear graph with negative slope. If you want to determine the order with respect for second order by using linear graph method, so plot graph 1 over concentration of reactant against time. And if you plot graph concentration of reactant against time and you get a linear graph with negative slope, it is a zero order reaction. Alright, okay. To determine the order of reaction by using linear graph, you will give an experimental data. You will give a set of experimental data. Usually, the data is more than 5 readings, and the question will ask you to use whether linear graph method to show that the reaction of X is a first order, second order, or zero order, or the question may ask you to plot appropriate graph to show that the reaction is a first order reaction, for example. And usually after you plot the graph, the question will ask you to determine the rate constant. So the rate constant will be determined from slope. Alright, okay, so I want you to try a tutorial question later on. And another one method is HalfLife method. From the plot of concentration of the reactant against time, the order of reaction can be determined. For first order reactions, the half-life is independent of the initial concentration. Thus, the half-life is equals to the second half-life. Right, if you plot graph concentration of a reactant against time, if it is a first order reaction, you will get a curve like this. But to determine the order of reaction for the reactant by using graph concentration against time, you have to find half-life, first half-life and second half-life. If the time taken for the concentration to decrease half from its initial concentration, which is called the first half-life, is equals to the second half-life, so it is a first order reaction. For second order reactions, the half-life is inversely proportional to the initial concentration. Thus, second half-life is equal to 2 times the first half-life. Right, as you can see here, this is the first half-life, which is determined graphically. And if you determine the second half-life from the graph, you will notice that the second half-life is 2 times from the first half-life. So that is second order reaction. And for zero order reactions, a sloping straight line is obtained. You will get a linear graph with negative slope. But to determine the order of reaction by using graph concentration against time for zero order, right, you will notice that the first half-life is more than the second half-life. So it shows that the reaction is zero order reaction.